In this set of probabilities, we're going to look at what's called at least probabilities. When I think about something happening at least once, that would mean it happens one or more times. The complement of an at least is that the event happens 0 times, or the event never happens. So let's look at an example here. The probability that a region prone to hurricanes will be hit by a hurricane in any single year is a 1 in 5 chance. What is the probability of a hurricane at least once in the next 5 years? I'm going to use a tree diagram to illustrate the idea of at least probabilities. You may remember from a previous video, when we look at a tree diagram, we have branches of the tree that are indicating events that are occurring in our probability. Here, we know that in any given year, we could have a hurricane and no hurricane. Those are the only two choices. You either have the hurricane or you have no hurricane. We are told that the probability of having a hurricane is a 1 in 5 chance. That implies the probability of no hurricane then would have to be a 4 in 5 chance. So, if it's a 1 in 5 chance it does happen, then it must be a 4 out of 5 chance it doesn't happen. And the reason is because both of those probabilities have to equal 1. Now these are the two outcomes, possible outcomes that you could have for the first year. Let's look and see what happens for the second year. Remember, we would still have two possible outcomes of hurricane, no hurricane, but this time we put our branches of the tree off of the previous year's possibilities. So we have hurricane, no hurricane, hurricane, no hurricane. Once again, the hurricane probability branch is a 1/5 and no hurricane is 4/5. Now I'm not going to do all 5 years, but I am going to do one more year just so that you can start to see the pattern that we're looking at. So here I've completed the outcomes for the third year, and that would be this last row that you see here. And so I have 3 full branches to the tree for possible outcomes or combinations of outcomes for hurricanes that could occur over a 3-year period. Now, what we are trying to identify here is we need to look back the probability of a hurricane at least once. So the probability of at least one hurricane. Well, let's look at our tree over here. If I'm looking at the probability of at least one hurricane, we've already said that the complement would be the probability of the event never happening. So to not have a hurricane, or in other words, no hurricane, is what we want to identify. There's one branch of the tree here, and it's this branch over here on the right-hand side, and that branch of the tree has only no hurricanes occurring. So year number 1, we have no hurricane. Year number 2, no hurricane. Year number 3, still no hurricane. We're on 3 years in a row with no hurricanes. However, all of this other mess, if you will, that I'm highlighting in yellow, are combinations of years that would entail having at least one hurricane occurring. So this is where the idea of our at least probability takes the complement and looks at the complement side in order to calculate it. So the probability of at least one hurricane can be found by taking 1 minus the probability of no hurricane. So 1 minus the probability of no hurricane, that's 4/5, and then the multiplication part of this comes into the fact that we would multiply for however many years we're looking at no hurricanes, because we would have no hurricane for the first year, no hurricane for the second year, and no hurricane for the third year, and so on. So we're going to multiply the 4/5 times itself for the number of years that we're looking at, and we would write that as an exponential form because that's shorthand for repeated multiplication. So The probability of at least one hurricane for 5 years, I'll put a fifth up there, can be found by taking 1 minus the probability of no hurricane for 5 years in a row. Now I'm going to show you how I do this on my Desmos calculator to quickly find this answer. So it's easier to put it in this scientific calculator than it is to use a cell phone. So I'm going to say 1 minus, and then 4 divided by 5, and we'll close that parentheses and raise it to the 5th power. And you can see over here on the right-hand side that the answer is 0.672. So it is a 67% chance that a hurricane will hit this area at least once in the next 5 years. So it's kind of confusing. At least probabilities are a little hard to grapple with at first, but it's easier if we will take only the complement of our event, right? The event that never happened, subtract that from 1, rather than trying to figure out the combinations for all of these possibilities over here in yellow.